Okay, to affect an alpha decay. Affect in this case means to cause. An alpha particle must borrow 27 million electron volts of energy, and that is, that's the barrier, right, through which it must travel. And this is, by the way, when it does make it through that barrier by borrowing energy, we say that it tunneled under the barrier, because the barrier, we draw them like this. It's kind of like, right, it's like, wow, like this, right? The alpha particles at this energy, and it somehow makes it through that barrier. And it does it quickly is what it does. The math here is not too hard. The first thing we got to do, though, is we got to turn that energy into joules, right? So 27 MeV, what we're going to do is go 27 million, right? That's what M stands for, times 10 to the 6th. And then we're going to multiply by the electron charge, right? So 27 times 10 to the 6th times 1.602 times 10 to the minus 19th is a fair amount of joules, right? So this equals 4.325 times 10 to the minus 12th joules. And now we're just going to plug that in for that and solve for the time, right? So let's do that. 4.325 times 10 to the minus 12th joules, right? Times whatever that time is that it's got. It can borrow it for that amount of time, right? And we'll just say equals Planck's constant, so 6.626 times 10 to the minus 34th over 4 pi. All right, so I guess I go 6.626 e minus 34 divided by 4 divided by pi divided by that answer that I just got, right? All right, and I get not very much time. Hurry up! We only have 1.219 times 10 to the minus 23rd seconds. Honey, hurry up! We only have 1.22 times 10 to the minus 23rd seconds to escape. But that might be enough time. Depends on how far you have to travel, right? All right.